The next assembly we're going to discuss is the model 709 series and the 909 series. 709 being a double check assembly, produced in sizes 3/4 through 10. The 909, same story, 3/4 through 10. I'm going to talk about these in two different size ranges, the 3/4 through 2, which on the 709 and 909 were bronze body construction. The 3/4 709 was produced from 79 to about 93 when it was discontinued. The 909 and 3/4 through 2 is still in production. Production began around late 70s, also 78-ish, 9-ish. Large stuff, meaning 2.5 through 10, started production around 79 and still in production today. The 3/4 through 2 inch was a bronze construction body, and the covers were bolted, as you see here, and there's a 3/4 inch picture showing one. Chest cocks pointing up, inlet outlet shut off like this. The 2.5 through 10 inch were a two-piece body design like you see this. Check covers from the top. The small ones, one cover was pointing up, one was pointing down, but this is a cast iron body that is fused epoxy coated. Inlet shut off, outlet shut off right here. I'll show you the arrows on the assembly because this one got confusing, especially with the 909 series, was the placement of test cocks, which we'll talk about in a minute. But anyway, it was a modular construction unit. When the covers came off the top, the check springs were contained, meaning that there was not spring tension had to be released for the average repair on 2.5 through 10. On the 2.5 through, on the 3/4 through 2, spring tension was contained when the cover was removed, but you had to release spring tension to rebuild it, which we'll show you in just a minute. The 3/4 and 2 inch, when you took the cover bolts off the top, the cover came off, but attached to the check cover was the check components for the first and second check. So removing the 4 bolts, cover came off, and the seat, disc holder, spring stayed contained and came out in one modular construction. The exploded view over here shows it. To disassemble the spring tension, you had to twist the seat a little 1/8 of a turn, and the little slots on the seat with the corresponding knobs on the back of the cover would hold the spring tension. There's your disc holder, and there's your check spring like that. On the large flanged 2.5 through 10 inch, check cover came off. The check assembly inside was not attached to the cover like the small sizes, but the check stem had a contained spring unit. Check assembly came out in one piece like this, and depending on the size, there was either one bolt on the bottom to remove the check disc, or on the larger sizes, there were a number of Allen head screws, 2, 4, 6 number Allen head screws that held the disc retainer onto the disc holder. The check seats were held into the body by 2 spring clips, 2 stainless steel wires actually, on the 4 through 10 inch. On the 2.5 and 3 inch, there was a bayonet design, which we'll show you in a second. So here's the check seat. Check seat was sealed by an O-ring. Check assembly sat through the center, so it was guided on the inlet side through the seat, on the back side through the spring retainer, and cover on the top. Spring was contained when we disassembled the assembly. The 909 3/4 through 2 inch bronze body construction, check cover on the top, first check here, second check cover on the bottom, relief valve cover off to the side here underneath the check mechanism, test cocks pointing up on top. The 909 series had a unique feature, and it was called the water in, air in, water out design of the relief valve. If you look on the bottom of the relief valve discharge, which I'll show you in a minute, there were actually 2 holes on the bottom of the relief valve. Most relief valve discharges have one large open hole. This one actually had 2. We'll talk about that in just a minute. The 3/4 through 2 inch check components, same as the 709 series, where the check seat held onto 4 little clips on the check cover. So when you took the bolts off the cover, the spring was contained. The whole check module would come out attached to the cover, and then once you had it on your workbench, you could disassemble it by twisting the seat and the cover. 1/8 turn rotation would release the spring tension. Relief valve stem was a single piece that set in the center of that relief valve. When you take the relief valve cover, the relief valve diaphragm nut would be exposed. You would pull this out through this way. Your relief valve disc actually sat on the back part of the diaphragm, with your relief valve spring on the far end of the stem. The large 909, same as the 709 cast iron body, fused epoxy coated. The relief valve actually flanged in between the 2 check bodies. Same check body as the 709 and 909, except this relief valve assembly bolted between the inlet of the second check and the outlet of the first check, and was attached by an external relief valve sensing line, a hose that went on the outside like this. 909 2.5 through 10, again, cast iron body, fused epoxy coated. Check mechanisms, same as on the large stuff. The check mechanism, same as in the 709 series. Check spring was contained for the average repair, and depending on the size, 2, 3, and 4 had one nut that held the disc into the disc retainer and over the disc holder, and the larger 6, 8, and 10 had small little Allen head screws that held that. The relief valve, and this is a side view of that relief valve, was unique because it had this air in, water out design. You can see the two relief valve holes on the bottom. In other words, this is the discharge on the bottom, but you'll notice this passageway in the center. What it was designed to do was to have one allow air to come in to the top of the area as water was discharged out the bottom. And we'll talk about that when we take it apart and look at it. Relief valve stem basically came in 3 different sizes, a 2.5 and 3 inch 909, 4 through 6 inch 909, and 8 through 10 inch 909. They did produce a 909 M1, and the M1 version utilized the 4 inch relief valve stem all the way up to 10 inch. So if you have a 909 M1 10 inch, it'll have the same stem as the 4 inch 909 relief valve only. If you have a 10 inch 909 without the M1, then you'd have to have the separate relief valve repair part over here. Be very clear when you have the M1 designation in the large sizes above 4 inch to make sure you get the correct repair parts. The relief valve body itself was made out of several different materials over the years. It was either cast iron, fused epoxy, or bronze, depending what size you had. 2.5 and 3 were usually bronze. The 4 and 6 inch were made in both bronze and cast iron. But the thing that changed on all those when they changed the size is what's called the spring button. And this spring button right here sits in the bottom of the stem. And that did cause a lot of problems getting the right relief valve button for the stem for the spring for the relief valves if you had the wrong model number, or sometimes you had to physically look at the relief valve body to determine if you had a cast iron body or a bronze body unit. So that's the 709 and 909 series. They made a 709 DCDA double check assembly, and they made a 909 reduced pressure detector assembly, 909 RPDA. They also had a standard model and an M1 model. You want to be clear which one, because sometimes the parts would be different. So let's go ahead and take it apart and see what it looks like. We're going to talk about the small sizes, 3/4 through 2 inch. I'll use a 909 because the check mechanisms are the same in the 709 as in the 909. Again, the 909 is still in production. The 709 double check is not in production anymore. But this offered some unusual configurations. The body looks relatively complicated to some of the other valves that we've seen. Our first check on the top pointing upwards cover, the check mounts to the cover, second check pointing down here, but the relief valve stem here is the part I want to show you especially. Here's a large 2-inch stem. It goes in the center just like that. I went through the cover like wrong direction, through like that to give you an idea what it looks like. So anyway, I'll take that apart in just a second. But I want to show you the body first of all, because what was unique in the 909 series was the relief valve discharge. And the relief valve discharge had 2 discharge holes in the bottom. And it was unique. For most ones just have one big open hole in the bottom. There were actually 2 coming out of the bottom. And if you follow up the body passageway, the relief valve diaphragm sits right here, and the relief valve disc was attached right below it, just right here, and the relief valve seat was right there. So the disc was attached to the diaphragm, moved, and then my relief valve spring was mounted over here on the back side of the stem. This orange silicone O-ring was a guide that helped it, mounted it, and if you'll notice where it traveled was right over this center bar right there. So when it was closed, this O-ring would go all the way to the back and seal on the back side. But when the relief valve stem opened, that O-ring would come out and then seal on this outer portion. Now, the reason it would do that has to do with this little side over here on the side of the body, where you'll see this little cutout right here. What that allowed to do was, when the relief valve would open up, it allowed air to come into the top portion of the check assembly. In other words, when this stem moved back across here and went from that bar there to that bar there, suddenly it would open up this outer area through here. Air would travel up through here, come out the back side here, and then come all the way up here, up to the top of the check assembly. So it would come up into here and come right through that assembly. So that, it also went to the top of the relief valve right there. So what it did is it broke the air. Now, what does that mean? When a relief valve discharges, this valve assembly is obviously pressurized. And when all of a sudden there's a back siphonage condition and there's negative pressure inside the body, what happens is that the area up here kind of creates a pressure lock. It's kind of like taking a Coke bottle and turning it upside down. And if you just sit there and turn it upside down, it just kind of goes glug, glug, glug and doesn't come out. But if you spin that bottle and get a vortex going and air goes up to the center, suddenly the water comes out of that bottle real easily. Well, the same principle is happening here. In other words, in a back siphonage condition, this relief valve down here will kick open, but the water in this body will not evacuate as fast as it will because, again, there's full of water and there's basically an airlock there. So to release that airlock, again, once that stem opens, it travels up the back side through this slot all the way to the top here on the top of that check, and also on the top of the relief valve diaphragm right there, so that now the body evacuates faster. That's the function of that air in, water out design, is so that in that back siphonage condition it breaks that vacuum and allows the water in the body to evacuate faster and discharge quicker out of the body. I've heard a lot of stories of what the air in, water out design does, but it's basically what it's doing is it's putting air in the body so the body will drain. Okay, now back to repairing a second. So let's take the check assemblies apart. There's going to be 4 bolts. And once you get the bolts off, there will not be spring tension on the cover, because the spring tension will be contained on the cover with the check assembly. It comes out in one piece like that. Our first check, second check. Just like this. All right, let's talk about the check assemblies first. Again, same checks as we'd see in the 709 as we see in the 909. First thing you'll notice, I've got a stainless steel seat and a plastic seat. Watts produced the 909 series in a cold water version and a hot water version. The cold water had a plastic check. The hot water had a stainless steel check. The cold water had a plastic disc holder. This is a brass one, but the hot water has a brass disc holder like this. The older version, the originals, were all brass on the check assembly disc holders, but the newer ones on the cold waters are plastic. Anyway, to disassemble this, like I say, a little 8th turn rotation off of the cover. You see the 4 knobs on the back, our check spring, our check disc holder, our check seat, which is sealed by an O-ring. Stainless steel version, hot water version, exactly the same, except parts like this. Now, this 3/4 and 1 inch 909 has another unique ability. It's the only RP on the market in the size that has a true vertical installation approval. By true vertical, I mean you can take it from horizontal like this to like vertical like this. Most assemblies have a vertically oriented approval, meaning that the check assemblies are mounted horizontal and then they move through elbows and fittings on the downside to give it a vertical orientation. But this one, you can actually take it in horizontal like this or vertical like that. And the reason is notice the positioning of the relief valve. Remember, to have a vertical approval, the relief valve must be lower than the first check. And that first check seat would be sitting right about here, just like that. So you can see that the relief valve is still below the first check, whether it's here or whether it's here, which is unique to this design. Most designs, that is not a true statement that when you go to the vertical, it is approved. And it went through the approval process and actually received approvals in vertical orientation in 3/4 1. The check seats were modified slightly when they got the vertical approval, and that was around 2003 that approval was given to them with that change in the check seat. But anyway, that's the basic check mechanisms. Back to the checks. The cold water unit and the hot water unit. Why does that matter? Because if you put hot water on a cold water unit just like this one, unfortunately, it will cause it to melt. And this shows you what the cold water disc holder, even though it had the stainless, the hot water seat, somebody put the cold water disc holder in this one and it melted right around there. But anyway, reassembly, check disc holders, go back in, check spring, covers have that little 8th turn rotation. The O-ring goes on the cover inside for the body. If it's a cold water version, it will have a plastic seat, plastic disc holder, reassembled to the cover. Again, that 8th turn rotation holds the load of the check spring. Reassemble. Your cover O-ring goes, you want to be very careful to put it on the body, right here. Put that on the body. Why? Because most people tend to put it right here. And what happens if you put the cover on the O-ring on the cover, as you go to put it in place, a lot of times it would fall down, and as you pushed it in, what did I just do? Just cut the O-ring. So to make sure that the O-ring didn't get cut, lubricate it properly, as always, all O-rings, and then insert the check in and the O-ring will stay in its proper location. Go ahead and get that in place. Get your 4 cover bolts. Second check, same story. Make sure you have the O-ring on the body. Once the body O-ring is in place, then insert the check stem into it, making sure all the way in. Get your cover bolts ready to go back on. All right, now let's talk about the relief valve. Again, the relief valve can cause some problems if you're not clear what that air in, water out design does. There are some interesting passageways in the body cavity that you're not clear what they're doing, and that's exactly what's going on. That's why we have the 2 discharges off the bottom. So to disassemble the relief valve, we're going to have some bolts on the relief valve cover, 4 on the 3/4 and 1, and I believe it's 6 on the 1.5" through 2. Once you take the covers off, cover bolts off, the cover will come out next, and attached to the cover will be this little nipple right here that sits right here. That's where my high pressure sensing line. Once that comes out, my stem assembly comes out in one piece, like this. Relief valve seat stays inside the body, doesn't have to be released for the average repair. Now, let's talk about this relief valve stem. Well, let's go ahead and rebuild it first. Relief valve stem has one nut on the back side of the diaphragm, diaphragm retainer, diaphragm, relief valve disc, and like we saw in the earlier versions, the relief valve disc is molded into a brass retainer, stem O-ring, right there, and disc retainer washer. Rebuilding is going to be just the reverse. Our disc retainer, our O-ring, and yes, the little O-ring has to be lubricated just as much as a bigger one. Relief valve disc, relief valve diaphragm. Now, if you notice the size of the stem versus the size of that cover, that diaphragm retainer are different. That hole is designed to meet the size of the ridge on the back of the nut. So make sure that that ridge sits in here just like this, because it has to be centered to get a proper seal on the diaphragm. So get it in place just like that. Then go ahead and tighten it down. Now, the bottom half, this is my relief valve spring. This does not have to be released for the average repair, but I'm going to go ahead and take it apart and show it to you. Because underneath there is an O-ring you want to be aware of. Right inside. Right inside there. I don't want to tear it. But there's an O-ring that sits in the center of this relief valve space where this O-ring is. And so if you do take that spring, take this apart, have to remove that spring for any reason, or the spring is broken or the stem is damaged, there's an O-ring in there. Make sure that it gets replaced. But for the average repair, it should not need it. For the average repair, all you're going to do is replace this relief valve stem O-ring, which is made of silicone. You can tell by the color. And the reason I want to show this to you, because this is a very, very important part of this assembly. Unfortunately, people find out it's important the hard way. This relief valve stem sits through here, and as I told you, where that spacer sits between those two pieces right there and on that side. And this O-ring, for the most part, is sealed on the back side right here, which is open to atmosphere. So unfortunately, it has a tendency to dry out. The Watts manufacturers provide a special form of lubricant for this O-ring. You can't just use a standard lubricant on this specific O-ring because of its construction made out of silicone rubber. You want to use the grease that comes from Watts for this. And if you read the directions on the grease, what it says to lubricate the O-ring. The O-ring piston, which is this piece here, and the relief valve seat bore, which is inside this relief valve seat. Because as you go to insert this stem, it has to go through the relief valve seat right there. So we want it to pass through there easily. And then when it gets loaded on the back side, it's very important that it slides all the way back there in a closed position and can come all the way back here in an open position. And that's why that O-ring has to be able to move and seal here and then also seal there. Well, the problem that causes is the stem has to move back and forth. Notice as I insert that stem in there, basically it's a blind assembly. I don't have the advantage of a cutaway when I'm out there repairing a valve in the field. And notice that relief valve stem, how that head of the bolt can sit right there. Notice right there, it's sitting on the lip. Notice right there, it falls into that recess. It's critical that that stem is all the way down in that recess. Unfortunately, if you have it right there, like that, you're going to bend that relief valve stem. And that's a relatively expensive mistake to make. So it has to be right there in that slot. And the shape of that bore that you see at the base of that relief valve seat all the way back in here is critical that the head of that bolt sits in there, that rounded slot. So how do we make sure that happens? Well, if you look, let's put this O-ring back on first, properly lubricate it. Put it onto my stem, lubricate on the outside. This is the one time after you lubricate the O-ring, you lubricate the bore of the seat right here and the piston itself. So what you want to do to make sure that the head of that bolt is sitting in that recess, not on that little knob like I just showed you, is we're going to push the relief valve stem in slowly. Again, I'm working from this side, so I have no idea if it's in the center. What I'm going to do is use the advantage of looking through my relief valve discharge. Notice that if it's in the right spot, I can see that O-ring right there disappear over to there. So once I know it's all the way back in there, it allows me to take a small little pen screwdriver and stick it in the water passageway, just like in the air passageway, just like that. Now, if you look through there, you can see that that bolt is all the way back into the slot. In other words, I can't compress that cover, that stem, all the way back in if that's not in its proper slot right there. So use the little screwdriver, put it in place. It makes it easy to put the cover on place. Why do I want you to do it that way? Because if you don't, this is a very common mistake. What happens is you push that stem in, and this bolt is sitting in that wrong slot like I showed you, and as you go to tighten the cover bolts, all it does is bend that relief valve stem, because the weakest part of that stem is right there. And I wanted to show you that, but I couldn't get the 1-inch one apart, but anyway, you'll see there. So that's why it's critical when you go to put it back together, if you're not comfortable with making sure you feel that that head of that bolt at the end of that stem right there is all the way in that slot, it'll bend at its weakest point, which happens to be right there in the center of that relief valve stem. And that's a relatively expensive mistake to make. So get in the habit of using this until you're comfortable with it. And once you're comfortable with that loading of that relief valve stem, then go ahead and you can do it without it. Anyway, relief valve cover goes back on. Get my this. With the screwdriver in there, I want to keep that in place till I get the cover all the way down, because that's going to make sure that that edge of that bolt sits in that little slot that I was showing you. Because if it's not perfectly in there, the cover won't go down flat either. So make sure that your cover sits flat. You know that the screwdriver was there. It gives you your indications that it's guided flat. Once you've got the cover on, then pull your screwdriver out. You'll hear that stem click back into place. And that's how we're going to fix the 3/4 through 2-inch 909s. Once we pressurize it, be sure and bleed the air out of it, air out of the top especially. And remember those air passageways, air does travel up through those, so we can bleed them out the test cocks when we turn it on. I want to show you a picture of a flange, meaning 2.5 through 10-inch 909, because there's some unique things we want to look at. First of all, inlet shut-off, outlet shut-off. This is the one assembly that has 5 test cocks, and a lot of times it confuses people where the test cocks belong. Well, number 1 test cock is always on the inlet shutoff, of course. The number 2 test cock happens to be right there. A lot of people look at this and go, there's test cock 2, there's 3, there's 4. If you hook up your test gauge like that, this valve is never going to work, because test cock 2 is here, test cock 3 is here, and test cock 4 is there. This is actually a bleed off of the air bleed off of the relief valve stem assembly. In other words, it utilizes an external relief valve stem assembly, hose that comes in from the bottom, and air does trap on the top of that relief valve diaphragm. So they built this little area over here and put this test cock on the top to bleed it. Most manufacturers use some small screw or some type of way of removing air. Watts just decided to use an existing test cock that they used on their backflow assemblies. And unfortunately, it got very confusing because there would be 5 test cocks, 1 on the gate valve, 2 here, 3, 4, and 5. So remember, when you're testing this assembly, it's critical that you hook your test kit up right. And there's test cock 2, there's 3, and there's 4. There's a little plastic piece of paper underneath the test cocks that identifies which test cock is which, but that doesn't hang around for more than a few years because it tends to break off, fall off, or deteriorate. Next thing I wanted to show you is the location of the relief valve sensing line. In other words, the high pressure sensing line is attached on the opposite side of the number 2 test cock. So this goes right in through here, comes through this hose, and comes up through the bottom, which I'll show you in just a minute. But why I want to show you where the location of that hose is, because unfortunately a lot of times we walk up to test this valve, after it's been installed for a lot of years, sometimes the test cocks will be plugged. We talked about the epoxy process earlier. So when the threads are not epoxy coated, what would happen is the test cocks would plug up. And how do we know that? Well, we go to put our hose in there, and all of a sudden no water comes out. We'd get our rod, drive it through, and flush out our test cock and perform our test. Well, that's fine, but remember our number 2 test cock is over here. So if we clean out this test cock, go ahead and hook up our test kit to here and here, we haven't necessarily cleaned out this line. In other words, this line is on a different port in the body than the number 2 test cock. So if this one is plugged and that one is clear, we can perform our test, but the relief valve will not open because we're not changing the pressures in the relief valve through the high pressure sensing line and the low pressure sensing line through the center of the body. So a lot of times people will test this, say, oh, I can't get the relief valve to open. Well, it's stuck closed. It goes all the way down and I can't open it. They think the relief valve is wrong. Well, usually what it is just the sensing line will be plugged. Because as we're testing that assembly, we've got to change the pressures on the inlet and outlet sides of that relief valve assembly to get it to open properly. So yes, we know the test cocks are plugged in our test procedure, but we don't always know if the relief valve sensing line is unplugged. Covers come off from the top, so we'll talk about that when we take one apart. The 2.5 through 3 inch had a bronze body option, and you could get that in bronze body, or the common one was cast iron, which was fused epoxy, which is what you see on the picture. But this number 5, the 5th test cock, was something that confused a lot of people, and I wanted to make sure you saw it.